Hi everyone, welcome back to the channel. In today's video we will learn about a theorem called Liouville theorem from the complex analysis. We will keep it simple with two examples. Before stating the Liouville theorem, we will try to remember two terms, that is entire function and the bounded. What does bounded mean? So let's move on. So what does an entire function mean? Before we state the theorem, we need the word entire. Means a function, let's say a function fz is called entire if it is analytic everywhere in the whole complex plane. That means there is no point where it fails to be differentiable. We can consider some example like function fz equal to exponential z, function fz equals to z square, and sine z are some of the entire functions. So entire means analytic on the whole complex plane. So here is the meaning of the bounded. Let's try to remember the boundedness. We need to get the idea of the boundedness function. A function is bounded if its modulus never become too large. In other words, there exists some fixed number m which is greater than 0, such that the modulus of the function is less than or equal to the value of the m for all complex number z. So here it is the statement of the Liouville theorem. It states that if the function fz is entire and bounded, then the function must be constant. In simple word, a function that is analytic everywhere and whose size never grows beyond a fixed limit must be constant. This is a very strong result. Thus, from boundedness and analyticity, we are forced to say that a function is constant. So let's take two examples. This is the first example. Let's take the function, a constant function equals to 2. It is entire because constant functions are analytic everywhere. It is also bounded because its modulus value is 2 for all the constant number z. So Liouville theorem says if it is entire and bounded, it must be constant. And in this case, it is constant, so the Liouville theorem here it is matched. Let's take the next example. This function is a non-constant entire function. It is a polynomial function, right? It is entire because it is not bounded, because the value of z, if the value of z tends to infinity, function value is also tends to infinity. Then it means the Liouville theorem does not apply here because the boundedness condition is missing. So it can be non-constant without any contradiction. Let's try to summarize what we learned today. If the function is entire and bounded, it must be a constant function. Another point is, if the function is entire but not bounded, it can be a non-constant function. So if this helped you, please like, share and subscribe, and let me know in the comment if you want a follow-up video on related theorem of the complex analysis. Thank you.